Welcome to Coach Eichner's Math. Today we'll be talking about Pythagorean triples and the converse of the Pythagorean theorem. So, as we previously learned, that when we have two sides of a right triangle known, the third side can be found using Pythagorean's theorem, which is a squared plus b squared equals c squared. Any group of three positive integers, a, b, and c, such as c squared equals a squared plus b squared, is known as a Pythagorean triple. Notice it is a positive integer, which means that it is a special set of numbers. For example, 3, 4, and 5. If I say 3 squared plus 4 squared equals 5 squared, well, 9 plus 16 does equal 25. So yes, that would be a Pythagorean triple. That is a special case where I have nice numbers to work with, and it's going to work out correctly, nice and even for us. Down below, here are some other Pythagorean triples that we may end up using as we go through the year. Take just a moment and write these down. If you notice, now that you've written these down, the first number seems to be climbing, and it's all odd numbers. We started with 3, 4, and 5 up above. Now we have 5, 7, 9, and 11 are all Pythagorean triples. And I want to point out as well that whatever the second number is, 12, there's only an increase of 1 to the third. 24 to 25, 40 to 41, 60 to 61. This won't always be the case for every Pythagorean triple, but I did want to point out that it does work and will help you remember those. Recall that given three sides, a triangle can be formed only if the sum of the two smaller sides must be greater than a third. So A plus B must be greater than C. So looking down below, which of the following can be lengths of triangles? Well, pretty simple. 4 and 5 is 9. 9 is greater than 6. So A could be triangle. 4 and 5 is 9. 9 is not greater than 9. So no, B could not be a triangle. Looking at the next one, 4 and 5 is 9. 9 is not greater than 10. So no, C could not be a triangle. So in this case, on example 2, A is the only opportunity we have for a triangle. Moving on. Recall that one way to classify triangles is by angles. A triangle can be acute, obtuse, or right. If a triangle can be formed, you can determine the type of triangle formed by comparing the squares of the longest side to the sum of the squares of the shorter sides, A and B. So, what this allows us to say is what we're talking about below. A right triangle can be formed when c squared equals a squared plus b squared. That's just Pythagorean's theorem. An acute triangle is formed when c squared is less than a squared plus b squared. An obtuse triangle must be formed when we say c squared is greater than a squared plus b squared. And a good way to think about that is as your hypotenuse gets larger, the angle across from it also gets larger. So if it's greater than equal, we're going to have an obtuse angle there. Looking down below, example number 8, determine if a triangle can be formed, and if so, classify it. So notice the very first thing says determine if it can be formed. So 4 and 5 give me 9. 9 is not greater than 12, so no, a triangle cannot be formed. We do not need to classify, so I'm going to say not applicable. There's no answer there. Looking at B, 6 and 7 give me 13. 13 is greater than 8, so yes, I have a triangle. So 8 is my C side, so I'm going to say 64. Is that going to be equal to, greater than, or less than 36 plus 49? 36 plus 49 would be 85. So 64 will be less than 85. So in this case, When c squared is less than a squared plus b squared, we have an acute triangle. So we would classify this triangle as acute. Looking down below, 1 and 3. Add up to 4. Well, is 4 greater than or less than the square root of 10? We want it to be greater than, so we can call it a triangle. So the first step I want to do is I want to look at it. Well, if I say 3 squared, 3 times 3 would give me 9, so the square root of 9 is 3. And the square root of 16 is 4. So that means that 4 must be greater because the square root of 10 is not going to be greater than the square root of 4. So we would say, yes, that is a triangle. If you get confused by that, you can type square root of 10 into your calculator and say 4 is greater than. Go ahead and do it real quickly. Okay, I'm going to turn on my calculator. I'm going to say second x squared, 10. 4 would be greater than 3.16228. So we do know it's a triangle, so as I go to classify it, I'm going to write c squared first, square root of 10 squared. And is that greater than, less than, or equal to 1 squared plus 3 squared? Well, 1 squared is 1 plus 9. Square and square root cancel each other, so I'm left with just 10. So I'm going to say 10 equals 10. And because 10 equals 10, we know that must be a right triangle. We know that because Pythagorean's theorem works. So looking over at the next one, 3 and 4 give me 7. And I've got the square root of 27. A good way to figure this out, if you don't have a calculator, is 7 squared would give you 49. So the square root of 49 equals 7. So I'm going to write square root of 49 and the square root of 27. Which one's greater? My two short sides. So yes, this is a triangle. Moving on, we're going to talk about c squared first, which is the square root of 27 squared. And we're going to ask, is that greater than, less than, or equal to 3 squared plus 4 squared? So that'd be 9 plus 16, or 25. We know that the square and the square root cancel out, which would give me 27, which would make c squared greater than a squared plus b squared. So when c squared was greater than a squared plus b squared, we had an obtuse triangle. So go ahead and come down here, and we're going to classify this as obtuse. Now, the one thing to be careful of, I did a good job of making sure I always put c squared first. If I don't put c squared first, I could end up flipping my sign and writing down the wrong answer based on what we're looking at. So make sure that you're looking at it and talking about, is c squared greater or is c squared less than when you are going to classify your triangle as acute or obtuse. Thank you for watching Coach Eichner's Math, and I hope you have a wonderful day.